Okay, on problem number 8 now. And 8 is 1 over 1 minus x. And they want me to center it at a equals 3. All right, let's review another technique. And I'm going to write this as 1 minus x to the minus 1. This going back to Taylor polynomials. And what do you have there? Well, you're going to get, let's see, 1 minus x to the minus 2. And then I'd see over here, there'd be a 1 there. Let's put the next derivative down. This is going to be 2 times 1, 1 minus x to the minus 3. And then I could put the third derivative down, and that's going to be 3 times 2 times 1, 1 minus x to the minus 4. And yeah, it definitely has a nice pattern to it. Let's write that down. So the nth derivative is going to equal n factorial 1 minus x to the minus n minus 1. Now what I'm going to do is evaluate these things at 3. So f of x, and I'll try to write them down very orderly now. So it's going to be minus 2, because 1 minus 3 is minus 2, to the minus 1. I'm going to start writing things down that some people say they're really not there, but I need to get a pattern. F prime, oops, I made a mistake. I just realized it. And it's good to look at what you're writing down. And I gotta erase this over here. And this is at 3. Sorry about that. This looks like 1 factorial minus 2 to the minus 2. F double prime at 3 is going to be, let's see, 2 factorial minus 2 to the minus 3. F triple prime at 3 is going to be 3 factorial minus 2 to the minus 4. And kind of moving along, the nth derivative evaluated at 3 is going to be n factorial minus 2 to the minus n minus 1. Well, I think I'm ready to write my series down now. And the series for this over here is centered at 3. So put this over here, 1 over 1 minus x is going to be, well, be careful about this. It's going to be, let's see, 0 factorial minus 2 to the minus 1. And then it's going to be x minus 3 to the 0 over 0 factorial plus 1 factorial minus 2 to the minus 2, x minus 3 to the, let's see, first power over 1 factorial. I think you get the idea here, but put another one down. It's going to be 2 factorial minus 2 to the minus 3, x minus 3 squared over, let's see, we're at 2, right? So 2 factorial. I think you get the idea, all right? Now certainly I want to write it down as a summation problem, and as I do that, it's going to look a little strange and I got to rewrite it, but I want to write down what I'm seeing over here. It just goes off to infinity, and I notice that the factorials are disappearing. 0 factorial is 1, 1 factorial cancels 1 factorial, blah, 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 blah. So let me kind of write it down as x minus 3 to the nth power, and that negative power I'm going to put down the bottom, by the way. So it's going to be minus 2 to the, let's see, I put it in the bottom, right? So it looks like n plus 1. All right, that's not so bad. And I'm going to write it a little different because I don't like the minus 2 in there. I want to see if it's, if I can write it as an alternating series. And let's take a look at that. And I'll put it on the side for you. And I'm going to erase it though. So minus 2 to the n plus 1 is like saying 2 to the n plus 1 times minus 1 to the n plus 1. All right? And, dividing by that is the same thing as multiplying it by it. So I'm going to put this over here as minus 1 to the n plus 1. I'm going to put down x minus 3 to the n, and on the bottom I'm going to put down 2 to the n plus 1. All right? Let me get the eraser out. It's something I do, like, I'm not going to say baby work, but I had to think. All right, that's an equivalent statement. All right, what I'm going to do now is I'm going to do the radius of convergence. So I'm going to do that by the ratio test. So limit as n goes to infinity. That's going to be minus 1. Let's see, n plus 1 is n plus 2. And it's going to be x minus 3 to the n plus 1 over 2. N plus 1 is going to be n plus 2 times reciprocal all right, that's okay. I've got to simplify that though, don't I? Equals the limit n goes to infinity. I'm realizing these negative things, the absolute values could be 1. And the 2 over here, I'm going to just cancel those things off. And what he left off with, just a 2 on the bottom. I'll put that down here. And this x minus 3, it's n plus 1. Yeah, it's going to be the absolute value of x minus 3. Well, it doesn't involve n. This limit's pretty easy, right? And that has to be less than 1. So let's solve that. X minus 3 less than 2, which means x minus 3 is between 2 and minus 2. I'm going to add 3 to all sides. I get 1, I get x, and then I get 5 over here. The length of that interval is going to be 4 units, so I can write the radius down. So let's go back up here. The radius is equal to 1. Let's put down I. I like to play it safe, by the way, and I want to test out the endpoints over here. So let's try the 1 first. Where am I? We're going to try the 1 in this one over here. What would you get? We're going to try 1. 1's the upper limit, by the way. Maybe we should write that down. It's going from 5 to 1. Put that down. 5 to 1. Let's try the 5 out, the upper limit. What is it going to give you? Let's see. 5 minus 3 is 2. 2 to the n. Right? Let's see what else you get. You get 2 to the n plus 1. If you're wondering where I'm plugging it in, I'm plugging it over here. And then you can get minus 1 to the n plus 1. And again, we're testing the 5 out. And what do you get there? Let's see, you get this. You get 1 over 2. And then you get minus 1 to the n plus 1. Well, this is clearly divergent by the test of divergence, so do not include the 5. Let's try the 1. And this is done. We tried the 5. This is where x was 5. Now we're going to try where x is 1. And what do you get there? Again, I like to play it safe. Again, I'm plugging it in where that highlighted red. So, you know, like, let's see, minus 2 to the n. And then you get minus 1 to the n plus 1. On bottom, you get 2 to the n plus 1. Some simplification to do, right? So let's see, minus 1 to the n, 2 to the n, minus 1 to the n plus 1, over 2 to the n plus 1. Let's keep writing that down. When you get there, you get 2. And then you get, you know, minus 1 to the 2n plus 1. Again, just by the test for divergence, it's a D and E again, all right? So I don't include that one either, all right? Let me get my eraser out, and I'm going to erase some doohickeys over here. And I want to go to my answer key now. And the answer key, this is problem number 8. And I'm going to look at it. Am I getting this over here? And let's see, n equals 0 to infinity, minus 1 to the n plus 1. Yep, I got that. Radiuses, oh, you know what? I wrote the wrong radius down. And I'll correct that, but I got this one down. As soon as you erase, it's always make mistakes, and you have to fess up to them. The length of this interval over here is 4 units. So what's the radius of it? It's half that number, which is 2. So I made a mistake. No need to do the problem again, but I do want to correct that. And what number goes over here? The number 2 goes over here. All right, my highlighter out again. Let me go back to the reading of it. And it does say ours too, so we're good to go. Thank you.